All right, students. Now, today we're going to talk about the shortest path. Now, usually when you come across questions like that, they will ask you how many different shortest paths are there to get from a single point to your destination. So, instead of counting the different paths one by one, there's actually a shortcut. And that can also help you to save time and avoid careless mistakes. So let's take a look at the questions, shall we? How many ways are there to go from A to B using the movements to the right and downwards only? So what they mean is to take the shortest path. Because let me show you something. If I were to go from point A to point B like this would be a shortest path. However, if I were to do this and I go back and I go back again, do you think this is the shortest path? I don't think so. So let's take a look. Do you notice that when you take a long path, you're going in the opposite direction? So that is why whenever we want to find the shortest path, we should never go in the opposite direction. We should also never go back up. Can you imagine if I traveled like this? Go up and come down again. Don't you think that this entire path was a waste of time and is definitely not going to be the shortest path? That is why we should only follow the directions to the right and downwards. Now, of course, it depends on the question, okay? If, let's say, I ask you to go from point P to point Q, then you should only be traveling upwards and to the right. If I were to tell you to go from point B to point A, then you should only be traveling backwards and upwards, okay? So this is logic. We just don't want to make unnecessary U-turns, right? So let's see, how are we going to count the number of shortest paths that there are? This is one shortest path. You can also count another one like that. That's 2. That's 3. That's 4. But students, do you notice that I can go on counting like that forever? That's 5. That's 6. I can keep counting on, and not only will it take a lot of time, I might also miss out some of the paths and result in a careless mistake. So let me show you how we should go about it. Let's break it down into different points. Instead of asking myself, how do I get from point A to point B, I'm going to take it one step at a time. I'm going to first ask myself, how am I going to get from point A to this point over here? How many shortest paths are there? One. Just one, because this is the only way to go. If I were to travel like this, it's going to be a very long path. If I were to travel like that, am I right? So there's only one way. And how many ways are there for me to get here from point A? From point A to this point? One as well, right? So everything along this line, there's only one shortest path, which is this. Okay, this direction. This would have been longer. This would also have been longer. So we will not do that. Now let's ask ourselves, how many ways are there to get to all these points? From point A, one way, one way, one way. Over here, also one way. Okay, next, I'm going to ask myself, how many ways are there to get to this point from point A? 2. 1, 2. There you go. 2. What about this? Let's see, okay? 1, 2, 3. There are 3 ways to get to that point. And the same goes for this. So now I've already counted how many ways there are to get from point A to several of these points. What pattern can you see? Now, do you notice that in order to get 2, it is actually 1 plus 1? 1 plus 1 equals to 2? What about 3? Do you notice that when we take 1 plus 2, we get 3? So what do you think will be the number of ways to get here? Let's take a look. 1 plus 3. 4. 1 plus 4. 5. Are you starting to see a pattern, students? Same goes for the vertical line. 4, 5. Now let's take a look here. What about this? If you were to take the two numbers which are closest to you, 3 plus 3, you get 6. What about here? 4 plus 6, we get 10. 10 plus 5, you get 15. 6 plus 4, you get 10. 10 plus 5, 15. 10 plus 10. Okay, so 10 plus 10 gives you 20 over here. 15 plus 20, 35. 20 plus 15, 35. 35 plus 35 is 70. So there are 70 ways to go from A to B using the shortest path. Okay? This is very closely related to this pattern over here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And it goes on and on and on. Take the two numbers above, add them together to get the next number. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus, and then the last number is just 1. So you start with the number 1. 1 plus 5, 6. 5 plus 10, 15, 20, 15, then 5 plus 1 is 6, and you end off with 1. And this pattern can go on and on and on. Okay? This is actually a very famous pattern called Pascal's triangle. So Pascal's triangle will help us to find the number of shortest paths. Now let's try another variation of this question. How many ways are there to go from A to B? But this time around, they have a condition. The condition is that you have to pass through the point X. Now, students, remember how I talked about the direction of the arrows? If you want to stick to the shortest path, you should not go backwards or upwards, right? You should take the logical, you should use your logic and realize that if you are trying to go from A to B, then going backwards will be a waste of time. Or if you were to go upwards, it is also a waste of time. So let me ask you, if you would like to go through point X, will you ever travel past point X? I don't think so. Because the moment you travel past point X, in order to get back to point X, you will have to go backwards. And this is already a waste of time, don't you think? So in order to go through point X and yet maintain the shortest path, please don't go past point X. Stay within the boundaries. So what boundaries should we stay within? Let me draw a box here. We would never want to get out of that boundary. Okay, let me use a different color. Okay, let's just use a highlighter. We would like to stay within this box, and we would also like to stay within this box. Now, let's go ahead and count the number of shortest paths. Once again, you ask yourself, how many ways are there to get from point A to the nearest point here? And the answer is 1, 1, 1. Now you take 1 plus 1, you get 2. 1 plus 2, you get 3. And let's continue the number 3 all around the boundary. Let me explain why, okay? Because there are already 3 ways to get here. And in order to go here, you are only following one direction. Okay. So let's go back. let's go back for a moment, okay? Why are we taking this plus this in order to get this? Because when you follow the direction of the arrows, both arrows are pointing to this point. So whatever number you have behind the arrow will get added and consolidated into this point. Okay, so let's take another example. Okay, for example, this. What direction is the arrow pointing? Here and here. So you look at the numbers which are behind the arrows, 10 and 5, you add them together, you get 15, right? So going back here, should this all be a number 3? How many arrows do you have? You only have one arrow. Do you have another arrow pointing here? No, because you're not going to go there. This is out of bounds. You are not going to go there. There are 0 ways, 0 possibilities, 0 ways for you to get there. So we will not be going there. So we only have one arrow to add. So you add this arrow all the way down. You add this arrow all the way down. Okay? If I had a number here, let's say I had a number 2 over here, and this arrow points here. Yes, okay, then I will take 3 plus 2, and this will be 5. But this is not the case because it is out of bounds. We only stay within our boundary. So that's the reason why it is all the number 3. Now, again, let's make use of the arrows. If I want to find the number at this point, I need to look at the arrow here and the arrow here because there are 2 arrows pointing towards this point. 3 plus 3. Okay, students, that will give us a 6. Now, what about this? Look at this arrow, 3 plus 6, you get 9. So you continue adding the 2 numbers, 9 plus 3, 12, 3 plus 6, 9, 9 plus 9, 18, 18 plus 12, 30. So there are 30 ways to get from point A to point B while passing through X. Okay, students? Now, there are 2 questions here that you can use for practice. Download the worksheet, do your practice, and let's see if you get the answer. All the best.